Okay, after we've talked about what innovation is, what we're going to do is we're going to move about how do you go about managing innovation, really? How do you do things in the firm so that you can actually get sufficient innovation? Okay. And to do that, I want to start by mentioning that innovation is a necessary evil, right? Evil in the sense that it's very risky, okay? So most new products fail, okay? The rate at which they fail, it depends on the industry, but oftentimes between 80 and 95% of new products fail. And by fail, I mean that within a year or two, their sales are way below expectation. Oftentimes expectation is to make money, especially after 2 years, but it depends on the industry. There's variation in there, but way below what was planned or expected. Okay, so why do I say it's a necessary evil? Because even though it's very risky, if you don't innovate, you will go out of business over time. You will become obsolete. And you can see some firms that have actually done that, and you do that at your peril. Right? So it's a necessary evil in the sense that it's very risky. So how can we mitigate that risk? How can we control that risk? How can we manage that risk of innovation? Okay. Well, let's see if I can get this to work. Here is one of the most traditional or typical processes that is used to manage innovation and innovation related projects in firms. It's called the stage gate development process, right? There are others, but this is like the innovation 101, right? And what this is trying to do is it's trying to minimize the chances that you will introduce an innovation in the marketplace and it will fail. Why are you doing this? Because like I said, the rate at which innovations or new products fail in the marketplace is really high. So what we're trying to do is we're trying to minimize that chance. We're trying to make it as small as possible. And to do that, what we do is we break down this process of innovation into different stages, right? This is something that's traditionally done. So the first thing that you will do will be ideation, for example, right? Which we have it somewhere over here. Let's see if I can show you in the diagram. So here you have ideation. What you do is you do some session, or you do, for example, some focus groups or any other technique to basically generate ideas, right? Okay. But in a stage gate process, what you do with those ideas is you introduce this idea of a gate in between the different stages. So after you've done your ideation, what you're going to do is you're going to evaluate your ideas. You're going to screen those ideas. And the way you do that is you will have a group of people. It could be just one person, but it's usually 2 or 3 people that are going to basically review each of these stages, right? The outcomes from these stages. And they're going to decide based on a set of criteria which one of those ideas, in this case, move into the next stage. Okay? And, the criteria are going to vary between stages. So, for example, the first stage, it could be the upfront uniqueness of the idea, how unique it is. Or it could be how difficult it is to get some of the technology that is required for the idea to work. Do we have some of that or not, right? There's going to be different criteria they are going to use to basically determine whether they move to the next stage or not, okay? But for sure, one of the first things that you're going to have here is uniqueness, right? It needs to be something really new. Otherwise, why bother, right? Okay, and new in a way that customers care about, right? Good. Okay, so that will be your first gate. And if an idea goes through that gate, then you'll take it into the next stage, right? And that next stage, it might be, for example, some preliminary investigation, where you're going to do some research into some of the assumptions that are necessary for that product or service to be valuable in the marketplace, right? So maybe you need to look into, what else is in the marketplace to make sure that nobody else is doing exactly the same thing that you're thinking about or very similar, right? Or it may be that you need to look into some patents that, maybe some companies will hold that might make your world difficult in this stage, right? And then after that, what you're going to do is you're going to have another set of people. It could be the same or different, depends on how you want to organize. Another set of people that are going to look at each of these ideas that have gone already through the first gate. And based on the data from the preliminary investigation, they're going to make another go, no-go decision, right? Out of the 10 ideas that went by the first gate, how many of those ideas are going to be feasible, right? At least up front. Maybe later you'll realize that they are not feasible really, but based on the research that you've done in this preliminary investigation or research, which ones are feasible. And you'll have some criteria. Based on that, you'll go, no go. And if from the initial 10, maybe 6 of them go to the next gate. And now what you're going to do in the next stage is build a business case. Business case is essentially going to be, how is this idea going to make me money, right? How are we going to get paid? Get at least a sense of what demand could be for this product, right? Maybe a rough market potential estimate that is going to give you an idea about how much money it's going to be in this space. Okay, based on that, maybe of the 6 ideas, you're going to have another gate here. Again, same people or different people are going to decide whether each of those 6 ideas are a go or no go, and maybe only 4 of them will fulfill the business case requirement. Then you will start the proper design and development, right? Now what you're trying to do is trying to create the actual product or the actual service in a way that will be feasible to be sold in the marketplace, right? And then you move to the next gate, right? Which is going to be basically doing some testing on those designs, right? Do they look like they are feasible? Do they accomplish the goals that we set up in the beginning in terms of customer performance, right? And for example, if you're building a new dishwasher that is very quiet, is the new dishwasher quiet enough? So you'll have a decibel number that you need to hit. And there will be different types of metrics. It could be 1, it could be 5. It really depends what your new product looks like, right? And then you're going to get to the next stage, right? And then you're going to get to the next gate. I think you get the point. And the idea here is you start with maybe 100 ideas. Then from 100, you get to 20, 10 or 20 here. Then you get to maybe 6 here. Then maybe you get to 4 here. Then maybe you get to 2 here. And maybe here, there is only 1 that makes it, right? Maybe 2, right? So the idea is that by the end, the moment that you actually get to the marketplace and you are actually launching the product, you have already bypassed all these different tests, and hopefully your chances of launching a new product that is going to be a failure are a lot smaller because you have minimized those chances, okay, by having all these tests that you have done to make sure that the ideas are actually, at least they have the most potential that you can foresee in the marketplace. Now, what are the nice things about this process, okay? Because it involves all sort of people, right? Because you're going to have marketing people involved. You're going to have finance folks telling you in the go, no go, for example, in the business case, right? You're going to have operations and engineering involved in the design aspects, right? This is going to really enhance cross-functional communication, right? It's going to enable different departments of the firm to talk to each other, okay? Also, it's going to make sure that you keep a clear focus. You know exactly what you need to do. You have each of those gates with clear requirements. So if you know that if you pass those tests, you're going to be able to move forward. So it really gives you a clear idea about what needs to be accomplished if you are leading one of the teams that has one of those projects under their belt, okay? Again, you're going to be looking at all sort of aspects of the product development, not only the product itself, but also the business case, also the marketing aspects associated with it. So it's a lot more complete, okay? And because of that, you're not just only talking about the product, but you're talking about the business associated with the product overall. So it gives you a more complete project where you're going to find the holes, not only in the product, but also in the way that product is going to be marketed in the marketplace. Okay, it also has clear go no go decisions, which is important because oftentimes there will be projects in firms that will not be killed and they will be just sucking resources, even though obviously they are not going anywhere. So the gates are put in there to make sure that to a large degree some of these projects are just not lingering around with no future, but still using resources from the firm, etc. Okay, good. Now, what are the downsides? One of the most important downsides is a very structured mechanism or a very structured process. And because of that, projects need to go through all the gates and you cannot move forward without accomplishing or bypassing each of the gates. Okay, and this creates difficulty, right? This makes you move slower. Maybe you realize right away that before the product can actually be considered further, you need to be doing a little bit of work that comes down the line because you're worried about it, but you cannot do that unless the other gates have actually been covered. So you cannot create a customized process that will enable maybe individual projects be treated differently because of the nature of the project. It will require maybe a different order in the different stage gate process. So maybe the development aspect should happen first because the business case can wait and it's dependent on how the product develops, maybe. Okay, so this idea of one size fits all, it's problematic, especially in large firms that operate in many different industries and they are dealing with products and services, and maybe some of the industries are very different than others. Okay, and maybe then the order should be changed, or at least it should be flexible. Okay. Another downside of this is looking at individual projects. It doesn't tell you anything about how to allocate resources across projects, but this is true of most tools that are used for management of innovation, at least of the ones that I'm aware of. Okay. Anyway, so the difficulty is very rigid. It's sequential. So because of that, you can bypass anything. It's one size fits all. It's everything the same. There is no flexibility. So there are some downsides, even though it's a good process when you're trying to minimize the chances of launching something that is not going to work. On the reverse side, because you minimize that chance, if you remember about statistics, which you probably forgot by now if you've ever taken a class, when you minimize type 1 error, which is what we're doing here by minimizing the chances of launching a product that is going to fail, you're maximizing type 2 error, which is the chances that you're going to kill ideas that have potential in the marketplace that, but for whatever reason, they fail some of your tests. So the fact that you're being very strict with all this process and the stage gate means that also you're probably limiting a lot of the innovation within the firm. So you need to be aware of that. Now, the alternative to this approach, at least conceptually, although I'm not going to go through a process, is the idea of working with the projects as though they are options. Okay, so this comes a little bit from finance, right? And it's looking at each of these ideas as an option, something that maybe you should consider investing some money in to see if in the future they are going to work or not. Okay, and the idea behind this is not trying to minimize the rate of failure, which is what we were doing before. We were trying to make the chances of failing as small as possible. Now what we're going to do is we're going to try to minimize the cost of failure. And I want you to understand these two things are very different, right? Why? Because the cost of failure is very different depending on when you are within this process. Early on, when you are at the ideation stage and all you've done is thinking about the idea for like 15, 20, 30 minutes, even if you have a team of 5 very skilled people involved in it, that only costs you a few $100s. Okay, that's assuming everybody gets paid a few $100s an hour. Okay, on the other hand, a product or an idea that has gone through all these stages and it's nearing marketing, right, in the marketplace, you have probably invested millions of dollars. So the cost of failing is very different if you are in the beginning stages or if you are in the end stages, right? But you need to understand that also the uncertainty of whether these projects are going to work or not is also very different, right? So I have here a stylized simplistic diagram of what's going to happen over time, right? And when you start early on, right, when you just come up with the idea, right, this is T0 times 0, right? This is when we're starting, right? What happens is you have barely spent anything. In fact, in the beginning, you have spent 0, right? You haven't spent anything. You don't even have the idea, right? And over time, the amount of money that you're going to have to invest in the project to move into the next stage, right, it's going to increase dramatically, right? So when you get, in the beginning, it's just a little bit of thinking, a few $100 maybe, right? But later you're going to have to build a business case that might take you a couple of days. So maybe you're talking about $1,000, $2,000 invested on that, maybe more, I don't know, right? But then when you get into the project development aspect and you start designing the product, there might be hundreds of thousands of dollars that are invested, or maybe millions, depending on the complexity of the project, right? If you're talking about building a new plane. So the rate at which you spend money is going to dramatically ramp up over time, okay? But also what you learn from investing that money is going to be a lot in the beginning and not so much later on. See, I want you to see this. This is the degree of uncertainty early on. In the beginning, you don't know anything about this. These are ideas you haven't thought about. You don't know anything about demand. You don't know about your competitors. You don't know if you can even build it, right? So uncertainty is really high. So just investing a little bit of money is going to make this uncertainty drop quite a bit. So I want you to realize, right, that you have an interesting problem happening right here. Right? If you invest a little bit of money, right, you're going to learn a lot about the product early on because there is a lot of uncertainty behind it, right? So if you look at the convolution of these two decision processes, right, okay, what you're going to see is that the actual risk, which is the product of uncertainty times spending. So if you multiply the purple diagram times the green, I will call it green, I don't know if it's green, diagram, which is your spend rate, the amount of money you spend. And that's what gives you your risk. Risk is the product between uncertainty, which is probability of something happening, and spending, or dollars, okay? So here you have your risk, which is what you should be managing, right? That's what matters. And I want you to realize that by investing a little bit early on, right, you're going to learn a lot. So you should invest a lot. So what you should do is you should fail a lot, but fail cheaply. Meaning you should invest in a lot of projects, small, tactical, strategic ways of investing so that you can learn a lot, make sure that the project actually is not going to work, and then dump it before you really make the heavy investment if you think it's not going to work. So what you're trying to do is you're trying to basically minimize the risk. Risk is at the highest right in the middle because you're spending quite a bit of money at that point and you still have a lot of uncertainty. Towards the end, your uncertainty is really low. You should know already if it's going to succeed or not in the marketplace. Yes, you have to invest a lot, but it's a good chance that if you thought it was going to work, it will actually work. So the idea here is instead of trying to minimize the chances of failure, what you should do is minimize the cost of failure. And to do that, what you need to do is you need to look at this as a portfolio of options, a portfolio of ideas, and you need to make cheap investments to learn as much as you can, as quickly as you can. And when you see that it's not going to work, dump it. But dump it early enough that you're not going to keep moving forward. So the idea is not to minimize the chances of failure, is to minimize the risk of failure, which is a different metric and it gives you a very different strategy as an optimal strategy. Okay. Now, we've talked about the process on how to manage innovation within the firm. Now let's look at it from a consumer perspective and try to do a little bit of prediction of what's going to happen with innovations. Now, if you look at innovation from a consumer perspective, what you will see is that consumers go through a process before they actually adopt a really new product. Okay. The first thing that they need to do is they need to become aware that the product or service exists. If they are not, obviously they're never gonna adopted. Then after that, they start maybe building some interest. Maybe they hear about the product from a friend. Maybe they see a review online. Maybe they see an influencer make a video on YouTube about the product. Maybe they see a commercial on TV, right? And that starts building some interest. Maybe I should look into this product, right? For example, electric cars, right? Maybe I should buy an electric car, right? Electric cars right now by sales are about 2% of the entire market, right? But they are the fastest growing car segment in the US, right? If you define it as a segment, right? And most companies are investing heavily on it right now. They realize that maybe the future is going in this direction, right? Then after a while, the consumer, what they're going to do is they're going to evaluate this product. They're going to start looking into it. They're going to maybe do some research. Maybe they're going to look at the specs. How much money will it cost? What will it do for them? Right? What are the downsides of the product? Yes, I need to charge it. It's going to take 30 minutes to an hour to charge fully in a supercharger. Okay, what does that mean for me in terms of traveling? Right? How dense is the network of chargers in the case of an electric car? Right? Is this going to be a problem? Is this going to prevent me from going to visit my relatives, let's say in Ohio, right? Which is, far enough away that maybe a drive from here will be roughly a 7-hour drive, and maybe your battery will deplete before you get there, right? So you're going to have to charge. Do I have options of finding charges in between that will enable me to make that trip? Why that trip? Because that's the one that matters to me as a consumer, because I have family in Ohio, right? If you have family, all your family here, maybe that doesn't matter, right? Then maybe you'll try it, right? Maybe you'll go and take a test drive. Maybe you have a friend who actually owns an electric car, and maybe you can ask them to let you try it, see, how it feels to accelerate 0 to 60 in 3.5 seconds, right? That's fun. It's like a roller coaster ride, by the way. And then finally, maybe you'll adopt the product. Adopt means buy in this case. Okay. Good. So what makes this process more likely to happen, right? What are the characteristics that a new product needs to have for consumers to actually go through all these stages and finally decide, yes, I want to adopt? First thing is, it makes it easier if the characteristics or the additional benefits offered by this product are observable, right? If it's something that I can be quickly made aware of how it's going to impact me, I'm more likely to adopt it. For example, if you tell me that I'm going to be able to charge the car at home and it's going to cost me each fill up about half of the money that it will cost me with my traditional internal combustion engine, this is something that I can right away tell what benefits it's going to have. On the other hand, if you tell me that image quality of a new TV that is in 8K, for example, it's going to be better image quality, I might not know what you mean by better. So it might not be as easily observable, and it's going to make me less likely to adopt the product, in this case, a new high definition TV, right? Relative advantage, how much better it is than existing products, especially than the product that I'm using at this time, right? So if I already have a car, right, how much better is the electric car than my existing car? Or if I'm buying a new product at the grocery store, how does it compare to the product that I usually buy, right? The degree of improvement is obviously going to improve the chances of you adopting the new product. The bigger, the better, right? Compatibility, this is the idea that sometimes you have already invested in products or services from the past, and when you buy the new product, you might not be able to use it. So compatibility is when you can use the old products that you already have with your new product. This is, for example, what happens when new video game consoles show up in the market, right? If you already have a video game console, for example, if you have a PS4 that is sold by Sony, right? When now PS5 comes in the marketplace, the question is, am I going to be able to use my old games from the PS4 in my PS5? And if the answer is no, am I willing to have two machines in the house? Now, if you're single, this might not be a big deal, but your wife might have a different opinion about whether you should be able to have two video game consoles at home or not. I can tell you mine has an opinion about this, and it doesn't seem to agree with mine. So compatibility or backwards compatibility with existing products or services is actually, or could be, important. So the more compatible it is, the more likely you are to adopt it, okay? So this is going to have a positive impact. Relative advantage is going to have a positive impact. Observability is going to have a positive impact, all in the adoption process. What about triability? This is when you can actually test the product. There are some products that can be tested, like a car. There are other products that might be harder to test, right? Like, for example, food that comes in a can, right? This is why sometimes in the supermarket you go there, and when there's new products, they might have somebody giving you a little taste of the product to see if you want to buy the product or not. Or if you're like my kids, just try the sushi and not buy any sushi anyway, because they love sushi, right? So the more triable the product is, the more likely you are to adopt it, because you're going to be able to tell by yourself whether it actually works for you or not. And complexity has a negative impact, and it's the opposite, right? If the product's really complex, it can do maybe many things, but it's not clear which one or which ones of those things are the ones that are relevant to you, then what's going to do is it's going to make it harder for you to adopt the product, because you're going to be less likely to know upfront whether it's going to work for you or not. Okay, so if the product does a lot of things, or if you need to read the instruction manual, you're a lot less likely to actually buy the product, because that's a cost that it's adding to the price. Okay, it's the cost of the complexity. Okay. Now, what I want to show you here is what happens in most industries. This is from real data, by the way. This is from music or content in general, although this refers to music as content. Okay, you can see these were vinyl albums, right? This is really old technology that was very popular in the 60s and 70s. These were around when I was young, like you guys. But you can see here something interesting is that over time, most new products get adopted, right? In the beginning, their sales grow slowly. You can see that with cassettes, which were a new platform for listening to music that was launched in the marketplace in the 70s. In the beginning, the vinyl LPs, right, were a lot more popular. The sales were a lot higher, right? What you have here, by the way, this is sales, and here at the bottom you have time. I didn't mention that. And what you can see here is the adoption of new technology or new products follows this interesting curve, right? And it always seems to replicate, right? It goes up and then it comes down. And there is kind of a very steep curve here, right? In the beginning, sales are really low, and suddenly they just ramp up and pick up, right? And you can see here the new platform that was launched in the 80s, which were compact discs, right? CDs, right? And then later, I don't have data for that, but later here in the 90s, you had DVDs, right? And in the 2000s, you have compressed audio like MP3, right? And then after that, you have streaming. So you can see there are all these curves that show up with new adoptions of innovation. And here's the interesting thing. When one new technology shows up, if successful, it will usually supplant old technology. So you can see here, albums went away when cassettes became popular. And then when CDs became popular, cassettes went away, etc., etc., etc. Right? So if you do not innovate, you will disappear. And what we're trying to do is we're trying to understand how this adoption of innovations happen from a consumer perspective. Right? We've talked about the factors that make you more likely to adopt or not. Now I'm going to show you a model that tries to capture this quantitatively. Now let me say up front, this content I'm going to tread lightly, and I'm going to try to not explain as much as I can, because it's a little bit more advanced. But I want you to at least be aware of the insights, the basic insight behind, because a lot of these modeling efforts, either here or in any other marketing arena, right now, if you want to do marketing, you will do a lot better in the industry if you have quant skills. Okay, so I'm going to talk to you a little bit about a quant model, just show it to you so that you can see some of the things that you can do with marketing data. But there is obviously a lot more to this, and I'm not going to discuss everything in detail. If you want to know more about it, I'm happy to discuss this with you offline. Okay. So let me show you what marketers have done when it comes down to diffusion of innovations, which is looking at this idea of whether a new product is going to sell or not, right? What we're trying to do is we're trying to predict how this curve is going to look like. What curve? The curve between time and sales. And by the way, when I say sales here, sales of the product category, not necessarily sales of an individual brand, right? So this will be sales, for example, for smartphones, not sales for iPhones, right? iPhone is just one specific one, but it will be iPhones plus Samsung Galaxies plus, all the other models that are actually sold in the marketplace, all put together by different years. If you plot them, you will see that we are somewhere around here. We're already at the peak when it comes to smartphones. I just don't have that data, but I'm sure if you search enough, you might be able to get something at least approaching to that. Okay, so the question is, can we predict when this peak is going to happen, right? If you could do that up front, that would be very useful, right? Because then you know what technologies to invest in. So if you have some idea of telling me how this curve is going to actually play out, and that would be great. The question is, can we do it? Okay, so people have tried to tackle this problem for many years, and a long time ago, a marketing professor at the University of Dallas, his name is Frank Bass, wrote a paper, and there's a story behind the paper, but I'm not going to bore you with that. Let me tell you the upshot of the paper. The paper is a little bit complex. If you want to read it, you can find the citation. It's one of the most heavily cited papers in marketing. Okay, but essentially what Frank did is he said, okay, when it comes down to the adoption of new technology or new products in the marketplace, there are two effects that drive the process. One is innovators. What are innovators? These are people that jump in, take the risk, and they just buy new things because they like new things, right? So this is something that is going to be maybe influenced by these people learning about a new product that exists in the marketplace. So for example, they see a commercial about a new electric car, right? Electric car that has a range of over 200 miles, which is like, wow, mind blown, right? In 2000, electric cars have a range of about 20 miles, not even 20 miles, right? And suddenly we go 300, right? So you hear about this maybe through mass media. Maybe you see a post of Elon Musk with his new Tesla Roadster, right? Which is the first car that they launch. And you get excited about it. Then you are an innovator, right? You're willing to take a risk and jump in. And then you have this other group of people that are imitators. Now, what are imitators? These are people that wait in the sidelines and see whether the product's worth jumping in or not. They don't want to take risks. They're, taking their time, and they want to be swayed. So they want to make sure that they have enough data to jump in. And data for them is most reliable when it comes from word of mouth, when it comes from other people who own the product telling them that, yeah, the product's actually good. Okay. Now, what he did in his paper is he basically created a formula or a formulation based on these assumptions. The assumption is that there's two types of people, right? Innovators and imitators. The innovators jump in and they get influenced by external communication, things like advertising. And imitators get influenced mostly by the number of people who own the product already, and because of that, they can actually talk to them and see if it's worthwhile. If you make this and a few other assumptions that I'm not going to discuss in detail, you can create a formula that tells you exactly at every point in time what your sales are going to be. And the formula looks like this, so don't be too worried about it. You don't need to memorize any of this. Okay, so what's interesting for us to know is what each of these things are. First is this is my sales figure, right? Which is what I want to know. I want to know how the sales pattern is going to change over time. Okay, and you can see here sales are a function of time. Okay, good. So it's a dynamic model if you want to know. But what that means is it depends on time. It doesn't just stay constant, it just changes over time. And then it depends on what? Well, it depends on a few parameters. Parameters are things that we don't know up front, but we know that they are critical to the process. And if we had some data, maybe we can estimate this model, right? We can estimate these numbers. So we have a few parameters here. First parameter is P, which you can see here, right? P is the coefficient of innovation, right? This is the degree to which people are going to jump in the market right away because the product maybe is attractive and they've seen it in a commercial or some sort of external influence, right? So this is the coefficient of innovation. The larger P it is, the more important the effect of this group of innovators is. right? Then you have another parameter called Q, right? And if you go here, Q is the coefficient of imitation, which is the strength of this word of mouth effect, right? This is how likely are people that are waiting in the silence to jump in just because they talk to somebody else. And what's going to happen is the more people they bought the product, which you will see it comes from this part right here, the more people have bought that product in the previous year, the more likely you are going to be to talk to somebody, and because of that, the more likely you are going to be to jump in and buy the product yourself if you are an imitator. Okay? Then you have M, which is the market potential. This is the maximum that is going to, the maximum sales that you're going to achieve. And in the case of these products, by the way, this model was originally for a product where you can only buy one of each type. So for example, if you're talking about homes, this model works really well because most people only have one home. I know your friend has 2 homes, but most people only have one. So when most people only buy one of the product, then this is a reasonable model. When you have 10, like for example, maybe you have 10 credit cards, this model doesn't work very well because it assumes that you can only buy one of the product type. In reality, you can expand this to make it more complicated and fit the scenario where you have multiple products, but I'm trying to keep it simple. So we're going to assume that there's only one product that you can buy at a time. So you can only have one video game console or one computer or one smartphone. If you have 3, then this model doesn't work per se. You need to modify it to make it more realistic. Okay? And then finally, you have yt minus 1. And remember, t is time, so t minus 1 is yesterday, or 1 period behind. If you are in years, it will be 1 year back. If it's in days, it will be yesterday, right? So it's the cumulative sales at time t. So this is the total sales that you have had added up every period until the year before. So this is the install base, or the number of products that you have sold total from the beginning of the launch of the product. Okay. And what you can see here, if you look at it a little bit, is that you have essentially 2 effects. One is the effect of innovation, which happens right here. Innovators jump in. The larger P it is, the quicker it's going to get this process started. So your sales are going to be higher if P is large. Okay. And then you have the imitation process, right? Which you have over here captured by Q. And it's going to be dependent. It's going to be a product of Q and this ratio between yt minus 1 and m, which is essentially the percentage of people that have already the product in the marketplace. You can think about this for a minute if you want, and see that because this is the number of people that have already the product, and this is the total maximum number of people who could earn the product. This is talking to you about how many people already have the product. And the larger this percentage is, obviously, the more likely you are to jump in and buy the product if you're an imitator, because there is a lot more likelihood that you will be able to talk to somebody about whether the product's worthwhile or not. Okay. So having this equation, and assuming that you know a little bit about calculus and some other things in differential equations, which is probably a grad level student topic, so I don't expect you guys to know this. You can show, and Frank showed in his paper, that the solution for that equation is this one, which looks ugly, but it's really easy to compute in Excel. In fact, I will post an Excel spreadsheet where I show you, actually I don't show you, but you have there the possibility of using this model as per this equation. And what this does is it tells you what your cumulative sales are going to be, which is that plot that we were showing, that diagram, okay, over time, and as a function of these parameters. And it's going to be able to estimate those parameters, M, Q, and P. These are the 3 parameters in your model. These are the things that you don't know until you throw in some data, and then with some data you can calculate from these equations, okay? And these M, P, and Q are going to uniquely characterize that shape of the curve. It's going to tell you whether it's going to take off quickly, it's going to take a long time, or if you will actually make it at all, okay? Now, the neat thing about this, other than people have written hundreds of papers using this model, and because of that, we have data, And I'm not going to walk you through this. I already explained, I think, most of this already. Let me show you how you use it. Here you have some P's and Q's based on data that has been published in many papers, okay? And what you can do with this is, if you have a new product that you're launching that has similar characteristics to any of the things that are in this table, you can use P and Q from these values already provided here. So if you're launching a new, for example, high definition TV that is similar to color TV because it has network externalities like color TV does, it's about content consumption, it's about the similar price point relative to income at the time, etc. So what you can do is you can use this P and this Q in here to predict what's going to happen with that new 8K TV, for example, right? Which is not color TV. Well, it is color, but the color is not the innovation, but it has similar characteristics to what is already on this table. And because of that, you can use the P and the Q here to predict how your new 8K TV is going to do in the marketplace. Okay, I'm going to stop here because I think this is a little bit more advanced. All I want you guys to do is get the intuition of what it does. It enables you essentially to predict what the cumulative sales are going to be over time if you have some data. And because of that, it enables you to know, A, whether a product's going to be successful in the future or not, meaning it's going to reach a peak or it's not going to reach a peak, and also when this peak should be reached, okay? It has downsides. There are problems like everything else. There are much more fancy and complex versions of this paper that obviously I'm not going to touch because that's PhD level material. But at least you guys have just a teeny glance of what this can do. And I will post an Excel spreadsheet that shows you that you can use this with actual data. Okay, that's it.